Have you ever wondered if using beam search in your training process could improve your results? If so, you're in the right place. Today, we're diving into the world of beam search and its role in sequence-to-sequence models. I totally get it. Many of us have faced the challenge of optimizing our models for better performance. It's frustrating when you know there's a better way, but the technical details can be overwhelming. You're definitely not alone in this. Here's the specific question we're addressing today. One user asked, if we use beam search in a sequence-to-sequence model, will it yield better results? They also mentioned that with the softmax function in each cell, beam search can't be used during training. So is there a modified optimization function that can work with beam search? Let's explore this together. So what exactly is the issue here? Beam search is a popular decoding strategy that can enhance the quality of generated sequences. However, its integration during training can be tricky, especially with the softmax function. Let's break this down. And stick around. By the end of this video, you'll have a clearer understanding of beam search and some alternative optimization strategies that could work for you. To address the user's question about using beam search during the training process, we first need to clarify that beam search is typically applied during inference, not training. This is because beam search helps in generating sequences by exploring multiple possible outputs. Next, the user should consider using a modified approach during training. One common method is to use teacher forcing, where the model is trained on the actual output from the previous time step instead of its own predictions. Additionally, the user might explore using a loss function that accommodates the beam search strategy. For instance, using a sequence-level loss function can help align the training process with the goals of beam search during inference. Finally, the user can experiment with reinforcement learning techniques. These can be integrated into the training process to optimize the model based on the quality of the sequences generated, similar to the outcomes of beam search. Fun fact, the concept of beam search was inspired by the way humans think. We often consider multiple possibilities before making a decision. Isn't it fascinating how AI mimics our thought processes? Now let's look at the answers provided by other users. One alternative approach is outlined in a paper titled Sequence-to-Sequence Learning as Beam Search Optimization. This paper details the necessary steps to incorporate beam search into the training process of sequence-to-sequence models. Additionally, there is a GitHub issue that provides a script capable of performing beam search. However, it's important to note that this script does not include any training logic. Let's take a moment to review another user's answer. This user points out that calculating loss at the individual word level can overlook the importance of sequence. They explain that a poorly structured sequence, even with random words, can have a similar loss value to a well-structured sequence. This is because the loss can be distributed across the vocabulary in various ways. Let's take a look at an answer from another user. According to another user, beam search is not necessary during the training stage of seek-to-seek models. Instead, they suggest using a teacher forcing mechanism, where the decoder receives a right-shifted target sequence. While beam search can enhance generalizability, it isn't practical for training. An alternative they recommend is the loss function called label-smoothed cross-entropy. Here's a pro tip. Experiment with different optimization functions and reinforcement learning techniques to see what works best for your specific model. This could lead to significant improvements in your results. And there you have it. Understanding beam search and its implications for training can open up new avenues for improving your models. If you found this video helpful, don't forget to subscribe for more insights and tips on optimizing your machine learning projects.